Guys, and welcome to Journey Through to the Centre of the Earth. This is activity 2 for Year 9, looking at continental drift. Okay, so firstly a little bit of history. So continental drift was first put forward by a Dutch map maker in 1596, Abraham Ortelius. And what he noticed when he was drawing his maps was the idea that the North and South America, their coastlines were very, very similar to that of Europe and Africa. This was backed up later on in 1620 by Francis Bacon, who basically looked at South America and Africa and again stated that they at one time might have been together because their outlines fitted just like a jigsaw. Okay, it wasn't until 1912 and Alfred Wegener, a meteorologist, basically suggested that at one time all the continents were together, and he called this massive landmass Pangaea. And about 200 million years ago, he theorized that Pangaea began to split apart. Now, at that time, that's quite a big thing to state, that all the land masses have moved over 200 million years from one place to the current position that we know of today. However, there is a lot of evidence that proves that that has occurred, and we'll look at that later in this course. Okay, so what sort of things are we looking at? Now, basically, this map here shows what Wegener was first proposing. You can see Pangaea together now, and if you look very, very closely, you can see on the left-hand side the South America, you can see America, you can see Africa right in the middle, you've got Asia up at the top right, then you've got Antarctica and Australasia down in the bottom right. And this was approximately 225 million years ago. Now, with time, the Pangaea landmass then began to split, and it split in half. We had Laurasia, which was the northern half, and then we had Gondwana land, which was the southern half, and they were split by the Tethys Sea. Now, you can see quite clearly now South America and Africa and the top of Gondwana land, and then obviously we've got India, and India's like that on that top portion of Antarctica down at the bottom, with Australasia on the top, on the right hand side at the bottom. Now these land masses are going to move again. So as they move again, you can now see how they split around. Now this is about 135 million years ago. Australasia and Antarctica are beginning to split apart. You can see the split in that bottom right-hand corner. And just above Australasia, you can see India. Now India is going to move upwards and slightly to the left, and it's going to burrow its way into Laurasia, or Asia at the top. And as it burrows its way and smashes in, that's going to be the formation of the Himalaya mountains. You can see South America, it's just tipped in the Cretaceous period in 65 million years, just at the bottom of Antarctica. It's going to start moving slightly up to the left, and it's going to join with North America, which is in that top left-hand quadrant in that second diagram. Finally, we get our continents as we see them now. We've got North America joined with South America. You can see Africa has moved across. You can see India has actually pushed into Asia, and you can see that dotted line showing the formation of the Himalaya mountains. We've got Australia and New Zealand. Notice that New Zealand has broken off from a portion of Australia, and we've got Antarctica at the moment at the bottom. Now you can see that Australia has gone in a northerly direction, so the predictions are that later Australia is going to smash into Southeast Asia, and who knows what's going to be happening then. Okay, so that gives you a rough idea of continental drift. You'll find that there are a number of videos that you can see on the course. I do suggest you have a good look at them. Some of them are very good, using some computer animation showing the movement of these continents as proposed by Wegener. And also we'll then start looking in our next unit at plate tectonics, which is really the driving force behind how these continents move. Okay, so thank you for watching, and join me again.